In 8.1, we discussed how you could actually do areas and volumes using definite integrals. And what we were trying to think about is how we could slice the shape up into an infinite number of pieces and add up the infinite number of pieces. So here we're looking at a cone. And we're going to slice this cone into an infinite number of these cylinders that we're looking at here. So if you think, we're cutting up those cylinders right there. And we're going to add up the volume of an infinite number of those cylinders over a height from 0 to 5. So we've got cylinders. And in this case, the volume of a cylinder is pi r squared h. The easiest number of those to pull out for us for this individual cylinder is actually the height. The height would be this delta y here. So far the volume of one individual cylinder is pi r squared delta y. Alright, so what we really need is the radius, and then once we have the radius, we'll have this formula, and we can do an infinite sum of them using a definite integral. So we need to think, how are we going to come up with this radius? Well, let's think, in general, this thing is about the shape of a triangle. And at any given point across here, we have a width. Then they're telling us this height is y. The whole thing has a height of 5. And the width of the base down here is 6. Okay? What we really want, we want the radius. The radius, if we're looking at our cone, that's going to be this area here. Or in other words, half of our W. So I'm going to make a note of that here. R is really going to be 1/2 of whatever the W we find is. Okay, so let's go ahead and find W. I would say the relationship here is Y is basically relating to 5, as W is relating to 6. And we want to solve this for W. So cross multiply. 6y equals 5w. Dividing by 5. W is 6 over 5y. But we don't want W for our formula for this cylinder. We want R. And R is 1/2 of W. 1/2 of 6 over 5 is 3 over 5. So R is 3 over 5y. So our volume now for an individual cylinder is pi times 3 over 5y squared dy. Our volume is pi times, if I square this, 9 over 25 y squared dy. That is the volume of an individual cylinder. But we don't want just one cylinder, we want this infinite sum of cylinders. So we're going to do the sum, or the definite integral from 0 to 5, pi times 9 over 25 y squared dy. This actually isn't too bad of a definite integral. You could do this by hand, or you could use your graphing calculator here. And when you compute this, it'll actually come out to be 15 pi. Which, interestingly enough, if you did the volume formula for a cone, 1/3 pi r squared h, you would actually get 15 pi also. So we know our definite integral worked. That would be the exact volume. But I believe if I asked you, and I think I did in this example, to find it to 3 decimal places, you could simply multiply 15 times pi, and you would get approximately 47.129 centimeters cubed, rounding to 3 decimal places.